Some quick background. I worked at the South Texas Project for 31 years. I quit in 2009, retired. I don't work there now, and I don't plan on working anywhere in the future either. So, anyway, this is an entrepreneurial proposal that I would make to the South Texas Project about building a wind farm on the property. Here we have the site map of the South Texas Project site. It's 12,000 acres. 7,000 acres is made up of this cooling reservoir, and that leaves 5,000 unused acres. Those 5,000 unused acres are from this side of the cooling reservoir next to the Colorado River. Now, important is that right here is our switch yard that puts our 3,000 plus megawatts onto the grid. So we have 5,000 unused acres and access to electrical distribution, which is huge. Often electrical distribution is, or accessing electrical distribution is one of the most costly objects of a wind farm, and we're not going to have that. Here we have a wind profile map of Texas, and what these colors are over here that gives the wind speed in meters per second. And this is measured at 80 meters because that's the normal hub height of a commercial wind turbine. Now here is South Texas in this area here. Let's get a closer look. Here's South Texas right in here. We can see that we're right around where the orange is, or the brown, which is over in here, somewhere between 6.5 and 7.5 meters per second. Now here's a wind turbine power curve, which is significant. As you can imagine, the faster the wind speed, the more power you can make. On the x-axis here is wind speed in meters per second. On the y-axis is output from the wind turbine in kilowatts. At South Texas is about 7 to 8 meters per second. We're going to be making about 1,000 kilowatts of power, or 1 megawatt. I think that we can get 20 megawatts of power out of a wind farm on those 5,000 acres. Here's how. We can install 20 turbines on that 5,000 acres. Now that's typical. It's going to vary based on the actual wind profiles that we'll measure. But 20 turbines is typical. At an average 7 meter per second wind speed, those 20 turbines will produce about 20 megawatts. Now, the average wholesale price of electricity is $20 a megawatt. So, 20 megawatts per hour times 8,760 hours per year times $20 a megawatt is going to yield $3.5 million per year of electrical sales. Before I get into some more of the financials, there are renewable incentives that are important. First, there's a business energy production tax credit, which is a 30% tax credit for the value of the property. That's significant. If there is a franchise tax, we will be exempt from it. There's a production tax credit, which is $23 per megawatt. That's huge for wind power. And federal loan guarantees. Wind turbine payback. At $3 million for the cost of a 2 megawatt turbine times 20 turbines, that's going to be $60 million. Now the cost of 20 turbines, however, with all the tax credit, is going to be only about $20 million, or about 1/3 of the cost of the real cost of the turbine. Payback is at $3.5 million a year, or in 6 years, we will have paid off the $20 million. With an average 20-year life of the turbine, 14 years times $3.5 million is going to be $49 million profit on a $20 million investment, which yields a 245% return on investment. Nice. Now the initial thing we need to do is build a meteorological tower to measure wind speeds at 80 meters so we can get the actual wind speeds. And we need to measure that for 1 year so we can determine the actuals, and then those numbers will determine the actual projections for the costs and the return on the wind farm. STP benefits. Besides the projected 245% return on investment, wind power is carbon-free power, just like nuclear power, which we promote, carbon-free power. The fuel is free. Customers are exactly the same. We don't have to find new customers. They're hooked to the other side of the wire. No water requirements. Very significant now. No water requirements at all for a wind farm. And we have a ready access to a transmission distribution system. And that means 20 megawatts may be available for emergency power to nuclear units if needed. During that time, there will be no reliance on incoming power or emergency diesels during an emergency. Are there any questions?